One common misunderstanding of the argument for evolution by natural selection is the assumption that while it might explain microevolution, it cannot explain the origin of new species or higher orders of life. Firstly, we must look at the process that causes new species to evolve. Speciation is the process where species diverge into new species. It requires reproductive isolation, which can be a result in many cases from allopatric speciation. Due to this isolation, gene flow between the groups stops. Natural selection causes the groups to adapt to new environments separately and become more specialized, producing two distinct species populations. The term microevolution generally refers to small evolutionary changes over relatively short timescales. These changes can occur at population or species levels. We can see in animals such as the European blackcaps, where over 30 years individuals within the original population have diverged due to a change in migratory patterns, northwest instead of southwest. Due to a new environment opportunity from increased food supply and warmer temperatures, some individuals have adapted to have new migratory patterns, northwest instead of the traditional southwest. It is now seen that the birds that migrate northwest have differently adapted wings and beaks for their new niche. Through this short period of time, the European blackcaps have adapted to different environments by natural selection, showing that natural selection can lead to microevolutionary processes. Microevolutionary changes in a population and the evolution of new adaptations can accumulate to the diversification of a new populations and species entirely. When we look at the creation of higher orders of life, the evolution of tetrapods often comes up as an example. It's a common belief that fish suddenly left the marine environment and grew legs, now able to survive in the terrestrial world. However, this evolutionary process happened over a time frame of approximately 15 million years through species like lobed-finned fish adapting to changing environments, slowly developing the traits needed to move on land. Although this event is now seen as a macroevolutionary event, the adaptations occurring through microevolutionary changes in primitive species were the primary building blocks to allow for the diversification and evolution of more complex life like we have today. Even though natural selection can explain microevolution, it does not act on its own. It is also a primary evolutionary process that acts alongside other processes to cause speciation and on a long-term scale form different orders of life.